Dear students, today we are going to discuss Kirchhoff's current law. Kirchhoff's current law states that in any electrical network, the algebraic sum of currents meeting at a junction is zero. Now, let us consider a simple T network consisting of resistances R1, R2, R3. Let the current flowing through the R1 is I1 and current flowing through the R2 is I2 and current flowing through the R3 is I3. Now this R1, R2, R3 are meeting at this junction point. I am taking that node as A. Now at node A the currents I1, I2 and I3 are meeting, but the current I1 and I3 are flowing towards node A and I2 is flowing away from A. Now if you take the incoming currents to the node, that is the currents that are flowing towards the node A as positive, then plus I1 plus I3. The currents which are moving away from the node A can be taken as negative, so it is minus I2. The sum of these currents plus I1 plus I3 minus I2, it will be equal to 0. So this is Kirchhoff's current law. Now if you move this negative point towards the right side, then we will get I1 plus I3 equal to I2. So I1, I3 are the incoming currents to the node A and I2 is the outgoing current for the node A. Therefore, you can also state the KCL as the sum of incoming currents is equal to the sum of outgoing currents at a junction. So in our previous example, I1 and I3 are the incoming currents, I2 is leaving current. Therefore, I1 plus I3 equal to I2, and the currents that are going to flow through each resistance can be calculated by using nodal analysis. So in that electrical network, if you want to find out the current that is going to flow through each branch, that can be calculated using nodal analysis. Let's see how to find out the currents. Let's take a simple example. So here I am considering again a simple T network. This is resistance R1, this is resistance R2 and this is resistance R3. Here the circuit is excited with voltage V. Now let us take the R1 resistance as 14 ohms, R2 as 10 ohms, R3 as 15 ohms, and the voltage source is 80 volts. So R1 is 40, R2 is 10 ohms, R3 is 15 ohms, voltage is supply voltage is 80 volts. Now let the current flowing through the R1 is I1, current flowing through the R2 is I2, and current flowing through the R3 is I3. This is node A. Now our requirement is we need to find out the branch currents I1, I2 and I3. For finding I1, I2, I3, you can apply the nodal analysis. Let the voltage at node A as VA. Let us assume the voltage at node A is VA. At node A, the voltage is VA. Now the current I1 is given by, at this point the voltage is supply voltage V V minus VA by R1, and I2 equal to, here the voltage is VA and this node is equivalent to this node, and it is almost equal to ground, and the voltage at the ground point is 0. VA minus 0 by R2, and I3 equal to VA minus 0 by R3. So I3 is flowing between this node and this node. So VA minus 0 by R3. Now I1 is flowing towards the node A, and I2 and I3 are leaving the node A. So according to KCL, now we can have I1 equal to I2 plus I3, and I1 is given by V minus VA by R1 equal to I2 is VA by R2, as VA minus 0 is VA, so it is equal to VA by R2, and this is equal to VA by R3, I3. Now I3 is given by VA by R3. Now V by R1 minus VA by R1 equal to VA by R2 plus VA by R3. Now I am moving this VA by R1 term to the right hand side, then we will get V by R1 equal to VA by R1 plus VA by R2 plus VA by R3. Now V by R1, if you take VA common, we are going to get 1 by R1 plus 1 by R2 plus 1 by R3. And now you substitute the values. V is 80 volts and R1 is 14 ohms. VA we need to find out, we don't know the value. 1 by R1 is 14, R2 is 10, R3 is 15. Now 80 by 14 equal to VA into LCM is 14 into 10 into 15. So here we are going to get 150 plus 15 into 14 210 plus 14 into 10 140. So 14 gets cancelled. 80 equal to VA into, so numerator 500 by 150 we are going to get. Therefore VA equal to 80 into 150 by 500. 0 0 0 0 gets cancelled. 5 1s are 5 3s are. So we are going to get VA as 24 volts. Now as we got the value of VA, we can calculate the I1, I2 and I3. I1 is given by V minus VA by R1. V is 80 volts, VA we got 24 by R1 is 14. So 80 minus 24 we are going to get 56 by 14. So it is 4 amps. Next, I2 equal to VA by R2. VA is 24 and R2 is 10, so it is 2.4 amps, and I3 equal to VA by R3, that is 24 by 15. So it is 1.6 amps. So by this way we can calculate currents in each branch. Thank you.